Okay, let's look at this question number 6, which is from this Monday's assignment, number 6. Okay, it's May 4th, Monday assignment for the number 6 here. We have a function here. This is a piecewise function, okay? But they said that f is to be defined by above here. Find the average rate of change of the f on the interval x greater than -3, less than equals 4, okay? First, we gotta be careful what's the meaning of average rate of change. Average rate of change will be equals to what? F for this value at the end minus the beginning, f -3, and then divided by the final x coordinate minus initial. Okay, so that's called the average rate of change. So you will have f4. F4 follow this piece of the function. So you're going to have -4 plus 3 times by cosine, right? Pi times by 4 over 2. So this over O, this over O. Okay, this over O belongs to F4. Okay, we just plug in the 4, x equals 4 back to here, and here we got F4. And the minus F -3 means we need to put the -3 here. So we have a 9 minus -3 squared over 4 minus -3 is 7. So from here, we can see that this part here, this part is cosine 2 pi, which equals 1. So 1 times 3 is 3, plus -4 will be -1. And this part is 0 and over 7. So that's the answer. This one just follow the definition of average rate of the change. So you can get this answer, okay? So now, let's go to the B now here. So when you go to the B, the question is what? Write the equation for the tangent line at the graph x equals 3. So this one, we just say you have any graph, right? We don't need to know exactly what the graph is. We just say any graph. And here, x equals 3, they told you that. And they ask you to find the equation of the tangent line like this. First thing first, we got to determine this point first. So x equals 3 belongs to this interval here, right? So we have to plug in 3 to here and here, okay? Let's find what's f3. f3 equals -3 plus 3 times by cosine, right? Pi times by x is 3 over 2. And we know this one equals what? 0. So that means it equals what? -3. So you have 3 and -3. That's the point. And then we need to find out, we know one point already. To find the equation of the line, we need to find what? The slope, right? How do we find the slope? We need to find the derivative of function when x equals 3, like this. So how do you find that? We can do this way here. We do f x derivative. Since 3 here, we're going to use this piece, okay? Negative x derivative is -1. And the plus 3, right? Constantly with the side. And then you're going to have negative sine pi over 2x, like this. This is just derivative to cosine. You will get negative sine of this one, right? And then use the chain rule, derivative inside here, which is pi over 2. So derivative of this one plus 3 times by inverse of time derivative of the cosine is negative sine. And then derivative inside here to the x will be pi over 2. And then you're going to do x equals 3, right? So f3 derivative will be equals to, this is -1. And then this part, and the negative here. So you have a negative 3 pi over 2, put it outside. And the sine pi over 2 times by 3. 3 pi over 2 sine will be -1. So this one will be -1. So you're going to have -1, negative, positive, so plus 3 pi over 2. This is the coordinate. Now, we're going to use the point and slope form to find this now. So point and slope form is this. They said what? Y minus y1, same as the slope, and x minus x1, okay? And then this y, that's the variable, minus f1. F1, just this one here, the points. Y counting up this point of tangency, right? So that means what? -3 equals slope. Slope means the derivative of the function when x equals 3. We got this one already. That means -1 plus 3 pi over 2. And then time by, this is slope, and time by x minus x1. x1, just the 3 here. That's the x1 of the point of tangency. That's the 3. So this is the answer, right? Of course, if you want, you can move this on this side. You get y equals what? -3, right? Because negative is positive, so +3, so you get a -3 on both sides. -3 and the plus 1 minus 3 pi over 2 and x minus 3. So this will be the answer for B, okay? For this one, remember, there are many times they ask for to find the tangent line of the function, right? Tangent function, we need the slope. We need the point, x1, y1. And they told you is that what? X equals 3, so you plug in 3 back to here, this branch of piecewise function. So you can find y equals -3. So that's why you got this one. Okay? So we're going to continue on this question to do the number, letter C now here. Why you do letter C? They ask you find the average value of the f, right? Average value of the f on the interval of from -3 to 4. So be careful. When we do average of f will be equals what? Integration. Find the total value of the f first. So you go from -3 to 4. Fx and dx. And then we divide it by what? 4 minus -3. This is the interval. right? So that's the definition for average of the f. So the key part for this one will be if we can find this one, we can find it, right? So now let's go back here, look at what's the function about here. You see, the function's like this. So when you do the, to find the average of this one, we simply do what? Integration from -3 to what? Follow this interval, right? -3 to 0, f x and the dx. And add by from 0 to full f x and dx, like this. And then we divide by this together will be just 7, okay? So what we can do is to find this one. And is this question belongs to calculator or not calculator? This one is what? Calculator? Okay, whatever. We can do it by hand here. This one, okay? We'll do it by hand to get an accurate answer. So we do this part first. All right. So we put this one as I1 and this one as I2. Okay. I do I1 first. I1, I put it here, equals what? Integration. This one is square root 9 minus x squared and dx, right? Get it? Okay, so when we do the find the average of the function here, we got this one, right? This definition of the average of the function value. And since this f since this f function is a piecewise function, so we have to go to 2 intervals from -3 to 0, and then from 0 to 4, right? And then the bottom one to 7, okay? Because 4 minus -3 is 7. So we have 2 integration to do. I put this one as I1 as I2. Okay, I do I1 first. When you do I1, we need to use a triangle, a trig substitution, okay? I'm doing like this here. So I make a right triangle here, like this. This one is a little bit like a trig identity substitution here. So we think this is an angle theta. And then by Pythagorean theorem, we can make this side as a 3 and this side as a square root 9 minus x squared. And this is the x like this. Why is like that? Because we know that Pythagorean theorem is right triangle. So from here, I can see this one equals 3 squared, right? And this is the x squared. So 3 squared hypotenuse squared minus 1 x squared and square root against the other one. So that's why I built up this kind of setting. Okay, this is called a trig substitution. And then when we have this one, we can see that from this triangle relationship, we can see that sine theta equals square root 9 minus x squared over 3. So we can find out the square root 9 minus x squared will be equals what? 3 times by sine theta. So I'm going to substitute this part by this. And also from this triangle, we can see that cosine theta will be equals to x over 3. So we can find that x equals to 3 cosine theta. And then dx will be equals to what? Equals to -3 sine theta d theta. Okay, cosine theta derivative is sine, negative sine theta. So all these formulas we're going to be very familiar with, and we can use it at the time we need to use it. Okay. So, and also the integration will be boundary from -3 to 0, like this. Just be careful. When x equals -3 here, okay, and just use different colors so we can tell. So if this is -3, and then, so we can have what -3 equal, you see, when we do the substitution, we change the variable x to theta and the dx to something d theta here, but we also change the boundary, okay? So let me prepare the boundary first and put it back one time. So x is -3, and we have a -3 equals to 3 cosine theta. And then when we got this one, cosine theta equals -1. And then theta we can see equals what? Equals to -1, so this is the pi. Cosine pi equals -1, okay? And also I'm using this boundary, x equals 0. So x equals 0, I put it here, okay? So you can have what? 0 equals 3 cosine theta. So cosine theta equals 0, and then theta must be equals to this is 0, right? So cosine theta equals to x equals 0, so 3 cosine theta equals 0. So theta will be equals to what? Pi over 2. So that means here, this boundary is pi over 2. This boundary will be pi, right? Okay. So when we have this, we can do the calculation now. So I can get what? I1, okay, equals what? I do integration equals to -3. This is theta will be from here, right? From the pi to pi over 2, like this, eh? And then this part, we know this one equals this. So we have what? 3 sine theta, right? And then we're gonna have what? 3 sine theta, and the dx here, dx equals this. We can put it as what? -3 sine theta d theta, like this. Yeah. So right now, I changed the boundary and also the variable integrand function always related to theta. And then we simplify a little bit. We take the -9 out, okay? So we have pi to pi over 2, right? And then when you have this one, okay, now, so we have this one here, we go, see here, -3, 3 times together is -9. Sine theta times sine theta is sine square theta, d theta, okay? And then we're going to use what? Half angle formula. Okay, sine square theta equals 1 minus cosine theta, or cosine 2 theta. Okay, because you see one question, there are many formulas used, divided by 2 like this. So I'm going to, why I'm doing this substitution? Because here is sine square theta. The square is hard to do integration. But if I change to this one, I can easier to do the integration, okay? So now we have -9 from pi, and this is pi over 2, right? And this one will be this one. So I plug it in. So you have what? 1 minus cosine 2 theta, okay? Divided by 2, and then times by d theta, right? Now this one, you can separate them now, okay? When you separate them, you can do like this. you can do it as I put it here, okay? So this is -9, I put it here. And then this half, dude, 1/2 integration, I just put about 1/2 theta, like this, right? And but here you have to put a boundary there from pi to pi over 2. This is one part. That's just this part, and time by d theta. Integration equals half theta, okay? And you have minus integration of the other one, which is cosine 2 theta over 2 d theta, like this. And that's the time also bounded from pi to pi over 2, okay? Now, from here, what we can do is this. In this part, just -9, I time it into here, okay? So you're gonna have what? 1/2 theta substitute pi over 2 minus pi, like this, right? And then -9 times by this negative is +9 and over 2 integration pi and the pi over 2 cosine 2 theta, okay? This is d theta, but I'm trying to change the same as 2 theta, so I put 2 theta here, but I got divided by 2 right here, like this. And why I'm doing this one, because we're going to do, okay, because this is 2 theta, this is 2 theta. We can think as a u, okay? Just the substitution. So that's the time we can get this part, we can simplify. That would be, this is negative pi over 2, right? Negative pi over 2, and by negative, so that would be 9 pi over 4. And do this one now, plus integration. Oh no, I can directly get it out now here. So we can get what? The cosine derivative will be sine 2 theta, like this, right? And then we plug in pi and the pi over 2, like this. But if you put a pi over 2 to here, 2 times pi over 2 is pi, sine pi is 0. And if you put pi here, 2 pi, sine 2 pi is still 0. So this part, no matter what, this whole thing is 0. This one equals 0. So the final answer will be 9 pi over 4. Okay? So that's this part here, we got it. So let's recall what we have this one. This one a little bit longer. Generally is this. What we did was, since they asked you, so we find this part already, right? We just find I1 right now so far, okay? It's not much yet. So we find I1 is what? 9 pi over 4. And just to do this one, we have to use what? Integration by set intervals, right? We cut into what? 2, we have to do substitution using the trig substitution here. See that? We got this one now. And then during this one, we have to use what? The trig integration formula and half angle formula. This one we use it here to substitute for here, okay? And here, the sine trig substitution to here, we change it to here, okay? So that's what we do so long, huh? But so far, what we did was what? We just finished this part now. We're not done yet. So we have to go to the second one now, okay? Second one a little bit easier. So I have to erase this part now, okay? So all this long work here just for this I1. So we find I1 equals to 9 pi over 4. Now we're going to this part now, okay? So now let me erase the parts so we can have the space. And I'm going to erase everything here first, okay? Just erase this part first. So make sure we have enough space to do the other part here, okay? So when we have, how can we do this part here? We go this way here. I2. This is I1. We did this already. We got I1 equals this already. Yeah? This is I1, okay? I2 now. I2 is integration from 0 to 4. When we go 0 to 4, we got to use this function now. We use this piece. So we have a negative x plus 3 cosine pi x over 2. And then dx. This one for this part is easy. It's negative 1/2 x squared, 0 to 4, right? And then plus this part, that's 3 here, integration. Now when you do this integration, be careful here, we have to do some substitution now, okay? So I'm going to use some substitution. So I'm put it here, okay? We do the substitution now here. When we do this part substitution, we go by u equals to pi over 2x. So du equals what? Pi over 2 dx, that? Okay. So now, and also boundary change, when x equals 0, u must be 0. So here, original is 0, so this is still 0. And when x equals what? 4. When this is a 4 here, so you have what? Pi over 2 times by 4 would be 2 pi. So this is 2 pi here, okay? And then the cosine pi over x, so we can put as a pi x over 2, we can put as cosine u. And dx, we're going to put this one in. So that will be pi over 2 dx, like this. Now, this is a negative 1/2 x squared. We're going to plug in boundaries in. So we're going to have 4 squared minus 0 squared, like this. And the plus 3. And then this part constant can be out. 3 pi over 2. And then the cosine u integration, this is du now, okay? Cosine u du integration will be sine u, boundary 0 to 2 pi. No matter 0 in or 2 pi in, this one equals 0. So this part always equals to 0. So this one here, you're going to have what? Negative 1/2 times by 16. So equals negative 8. So now we find out the I2. Now what I'm going to do is I put the final answer on this part here, okay? Is this. So the average of function, right, equals what? I1 we found is 9 pi over 4, right? And the plus 0 to 4, the second part of the I2 we found negative 8. So you got a negative 8 and divided by 7, like this. Or you can write this one as maybe nicer. Okay, this is the answer already, but we can make it nicer. We can put like this one, 9 pi over 4 minus 8, like this. So this is the answer. Yeah, this one a little bit long, just because of this integration. The first one takes a longer time on that, okay? So we have one more. We finished A, B, C, and then we have D right now, okay? We're going to the D right now. So when we go to the D, I have to clear everything first, okay? We go to D now, okay? So when we see the D, let's go here, D. P, they said what? Must there be a value, right? Must there be a value of x at which fx attains an absolute maximum on the closed interval of -3 to full inclusive. On this one, make it simple. Use the plain language. Just say they should have that. They just say fx should have absolute maximum. Absolute maximum is the highest point in between -3 and the full of the function value. Okay, that's the one you want to show. How do you show that? We're going to let's go back to the beginning function here first. Okay. We learned the theorem is this. The theorem said if function fx continuous, then continuous in the closed interval of a, b, okay? Here just what, -3 and 4, okay? Then the fx should have what? Should, or you can put like this over here. So that means then their absolute, right, maximum or minimum. Okay? No, you should have absolute maximum, also absolute minimum, and it's not a or. That's the theorem about. Okay? As long as the function in the closed interval continues, means no hole. If there's no hole in the closed interval, the function should have the maximum and a minimum. So when we do this one, we know this function is continuous, this branch of the function continues within this interval. This one also continues with this interval, no problem with that. So the only point where it may not be continuous is at x equals 0. So I'm checking right now, okay? I check x equals 0, f x continuous. We're gonna check on that. We don't know right now, okay? I check. So I check this way here. Limits x approaches 0 from the left side, okay? From left side falls into this interval. So fx will be equals to, you plug in 0 here. So you're gonna have square root 9 minus 0 squared equals to 3. And also we check limits x approaches 0 from the right side of the 0 go to fx. Right side should be this one. So you're gonna use this piece of the piece function here. So you're gonna have what? 0, -0, plug in here, 0 here, 0 here. And the plus 3 times by cosine, right? Pi times by 0 over 2, like this. So you're gonna have, this is a cosine 0. Cosine 0 equals 1. 1 times 3 is 3. 3 plus minus 0 is still 3. See here? Left limits, right limits equal. And then we're gonna put f3, value of the function. F0. So we're gonna check on the value of the function right now. F0, because 0, this is equal sign here. So you're gonna use this now here. So still equals square root 9 minus 0 squared equals 3. You see, the left limit at 0, right limits at 0, and the value of the function at 0, all of them same. So this shows that fx continuous at x equals 3. Okay, now x equals continuous at x equals 0. Oh no, at x equals 0. Okay, at x equals 0. So we know x equals 0 continuous, and also it's from -3 to 0 continuous, from 0 to 4 continuous. So that means what? Fx, from there we can see fx continuous from close interval -3 to 4, including -3 and 4. So if you have the bound, like this function continues at this one, so guarantee what? There is a maximum occurs. Of course, there are minimum, but here this question, they just ask you absolute maximum occurs. So that means yes. Okay, the answer is yes. There is the maximum, absolute maximum, means overall global maximum within the interval, close interval of -3 and 4. Okay, so that this way we showed our work and get the answer. All right, so this one is pretty long, but please watch carefully. And the really important is that you need to do it by yourself. Okay, I did one step, one after another, show the detailed steps. You gotta do it. When you do it, and then you will get a benefit from this whole procedure. Okay, so please let me know if you have any questions. Thank you. Bye-bye.